Hey everyone, ever feel like your high school math class was a little weird? Like there were some things that just didn't quite add up, some concepts that seemed to bend the rules of reality? Well, guess what? Your math teacher might have been secretly introducing you to postmodernism. Now, I'm not saying your algebra teacher was quoting Derrida between quadratic equations, but some of the core ideas of postmodernism, challenging absolute truths, embracing ambiguity, questioning rigid structures, are actually baked into the mathematics you learned in school. Let's start with geometry. Remember parallel lines? The definition, drilled into your head, two lines in the same plane that never meet. Seems straightforward, right? But then things get complicated. What about projective geometry, often touched upon when discussing perspective in art? In projective geometry, parallel lines do meet at a point at infinity. Suddenly, that seemingly absolute rule about parallel lines isn't so absolute. This is a subtle but powerful example of how mathematical truth can be context-dependent. It depends on the system you're working within. Euclidean geometry has its rules, projective geometry has different rules, and they're both valid within their own frameworks. This hints at the postmodern idea of relativism, the notion that truth is not absolute but relative to a particular perspective or framework. Then there's zero, the humble zero. Seems simple enough, right? It represents nothing, but zero is a surprisingly slippery concept. Is it a number? Is it a placeholder? Is it the absence of quantity, or is it a quantity in itself? You can't divide by zero. Why not? Because it leads to contradictions and absurdities. Zero throws a wrench into the otherwise orderly machinery of arithmetic. It's a point of indeterminacy, a place where the rules break down. This kind of ambiguity and breakdown of rules is a hallmark of postmodern thought. And what about definitions themselves? In math, we rely on precise definitions. A triangle is a three-sided polygon. A square is a quadrilateral with 4 equal sides and 4 right angles. But even these seemingly solid definitions can be deconstructed. What if we start to bend the sides of a square? What if we move into non-Euclidean spaces? At what point does a square cease to be a square? The boundaries become fuzzy. This echoes the postmodern critique of language and definitions, the idea that words and concepts are never perfectly stable, that their meanings are always shifting and context-dependent. So, your math teacher, probably without even realizing it, was exposing you to ideas that resonate deeply with postmodern thought. The relativity of truth, the ambiguity of concepts, the limitations of formal systems, and the inherent instability of definitions. Math class wasn't just about memorizing formulas. It was a subtle introduction to the complexities and contradictions of knowledge itself. What do you think? Did your math education subtly challenge your assumptions about truth and reality? Are there other mathematical concepts that have a postmodern flavor? Share your thoughts in the comments. And if this video made you rethink your high school math experience, be sure to like and subscribe. Thanks for watching.